Hello everyone, are we live? Just let me know in the comments if I am audible and if everything is right. And sorry to keep you guys waiting for such long. I was facing some technical issues from my side, and that's the reason I had to postpone this stream like almost 45 minutes or an hour later. But thank you very much for sticking to the live, and I hope is everything all right. Just let me know in the comments if I am audible and if everything is proper, and I will check it on my phone as well. Hello, hi Shivam, are you there? Yeah, I guess we are live and everything is audible. Yeah, so today's stream was something which many people requested me to make, which was I was recently testing out the Spot Mini package, simulation package, and everybody said that please tell us how we can do it. So yeah, today will be that thing, and instead of just giving you a complete go through do this and do that, instead of that I will be sharing my journey, exactly like how I landed upon this thing and how we will be going through it, like what all problems I faced. So this PC that I have right now, it doesn't have any Spot Mini packages installed, so if we face any problem we will be solving it in real time. So I will be showing you the debugging process as well. So without any further ado, let's get started. Hello Gautam. Yeah, so I wanted to simulate this Spot Mini package from very long time. Okay, so even before ClearPath announced the Spot Mini was they announced their own ROS package. Even before then I had like ideas that Spot Mini might be working on ROS because it is like universally loved thing. Okay, it's universally accepted as well because each and every robotics engineer usually uses ROS. So I had a pretty confidence that ROS might be using ROS. The Spot Mini robot might be using ROS. So I did a little bit of research and I came across the Boston Dynamics package. So I will show it to you right away. In just a minute. Yeah, so if we so if we go to if we just search on internet, this is what I did, like Spot Mini ROS package, and literally I found nothing apart from this ClearPath blog. This was one thing which I found. So if we go through the blog, they say that the ROS has been enabled on Spot Mini. Okay, but if we go through it, they also show that all the sensors around the Spot Mini. So Spot Mini has around total 5 Intel RealSense on it, which are depth cameras. So using those 5 Intel RealSense depth cameras, it makes a 3D map like this around it. Okay, so these 5 cameras are like 2 in front, which are placed vertically. So technically these are horizontal sensors, but they have been placed vertically in the front. They both cameras stitch together the images to form a proper front view of the robot, and then it has one on each side, a total of 4, and one on the back. Okay, so this is how it has total 5 depth cameras which it uses to make a 3D map of the surroundings, something like this. Okay, and I went to the ROS driver package and I could find that they had a Spot ROS package, but it was just if you have a real robot. If you spend $75,000 on a robot, which is around 56 lakh rupees in India, if you spend that much to buy a robot, only then you can use this package. So I will show you what exactly this package has. Okay, so let's check if it has the installation thing. So yeah, so we need this prerequisite. So let's copy this prerequisite and let's download it as well. So I have this terminal over here. I will be using Python 2. Okay, so instead of pip3, I will be typing pip, just pip and then sorry, just pip, and then I will be pasting this. If you are using ROS Noetic or any other things, or you have made your ROS on let's say Python 3, then you can use pip 3. But right now I just wanted this. Okay, pip is not installed. I will just install it. Sudo apt install Python pip. As I said, this is a completely new PC. It doesn't have anything installed on it, so everything will be some so the experience of this PC will be something like you guys might be having, like where everything is not installed on your PC. You might face some issues, you might face some problems, just like we faced problem right now for pip. So I'm installing pip, and then I will be installing those prerequisites. Okay, so yeah, I guess it's done. By then, let's check out chat. Yeah, it's done. Now I can install these prerequisites. I will let them install, and until then we'll check some chat. So hi Nagu, yeah, I will definitely try to make it piss in a beer cup. Okay, yeah, even I am a fan of Michael Reeves, and yeah, definitely I will try to make it piss in a like I will make that controller package to piss it in a cup, maybe in some future video. But right now we will be just setting it up. We'll be setting it up on a blank PC. Okay. Is there any prerequisites for the session? No, Aman, there are no prerequisites for the session. As I said, everything is being installed right now, so there is zero prerequisites. Okay, not even the RUR live stream. This is completely different from the RUR live stream, so you don't need any prerequisites. Just follow the steps as I am going through, and this live stream will be there on my channel later on as well, so you can refer to it whenever you want later on. Okay. In the meantime, grab some popcorn. Thanks, Dinesh, to keep people waiting on the live stream. Hi, I have the chance to say that. Thank you. Thanks, Andre. Oh, thank you very much, Andre. I am glad to hear that my content helped you a lot. You're welcome. You're welcome. Yo, Shubham, yo. Can you stream on 1080 pixels? It is hard to read the terminal. I guess I am streaming at 1080 pixels. Let me check. Am I not streaming at 1080 pixels? It has been streamed at 1080 pixels. I guess it will be available in full HD once the complete live stream is over. I will check it on my phone as well. Just a minute. Yeah, so currently the live stream will be at 720 pixels, but later on, once it is published, at that time it will turn it to 1080 pixels. So I guess there is no option other than waiting. Okay. Yeah, I guess same, Pandya. I will just check once again if everything is on 1080 pixels. Just wait a minute. I will try to upscale it. Yeah, is the stream at 1080 pixels now? Could you guys check it? Could you guys please check if it is at 1080 pixels? Okay, Sahas, let's like I have changed the resolution right now and it is at 1080 pixels. So let's move ahead and let's see if it is available or not. Okay, how ROS 2 is different from ROS 1? That's a really great question, Rajmeet Singh. I am right now making a video which will be telling how ROS 1 is a lot different from ROS 2, and I will be also explaining pros and cons of both of the things. And it's not like that people work on ROS 2 now. If you're a company who is making a product which will be launched 1 or 2 years later, only then people are shifting to ROS 2. But if you are a company who is working right now into industry, and if you have production grade robots right now which are working, so in that case everybody is using ROS 1 and they are using ROS Melody. Okay, it's like if you go on any industrial based robot right now, may it be Boston Dynamics Spot or may it be Auto by ClearPath Robotics, all the ClearPath Robotics robots which are used in industries right now, so all those robots are using ROS 1 currently. They're shifting to ROS 2 step by step, but still ROS 2 is not yet stable on many systems. So that's the reason everybody like in industry, if anything goes wrong, it's really difficult for them to manage everything. So that's the reason everybody's sticking to ROS 1 right now. But if you are a new company who is going to launch products, so that time those people are working on ROS 2. So that's the thing. Okay. Thanks Sahas to let me know that it's in 1080 pixels. That's great. Okay, then yeah, so our these packages, the prerequisites are being installed. So I will add this in camera. Yeah, so yeah, the prerequisites are being installed, so that's done. Now what we need to do is we need to clone this package. So where should we clone the package? So into the src folder where all the packages are there. So I will just copy this thing. Okay, I will open up the terminal. I will go into the src. So cd catkin workspace src. Here if I do ls, I have all the different packages that I am working on. So right now what I will do is I will just paste it, but this was just the path. So before that I will do git clone and done. It will download the Spot ROS package. Aman, is the stream stopped? I don't think so. If anyone is in touch with him, let him know. Is the light working or not? I guess it's working. So, now I still watch. Now 10:29 I'm still watching. Yeah, that's great. That's great. Not stream it isn't ended. Okay. I guess that I'm facing some problem today, but no worries. Maybe Boston Dynamics is doing something suspicious because I am revealing all their secrets tonight. So stick with the stream. I am there. Don't worry. I am not going anywhere. I will be telling how you can simulate Spot Mini packages. So don't worry about that. Okay. Maybe it is happening because I am going to like cost $75,000 to them. So maybe that's the reason we are facing some problem, but never mind. So I have cloned this git package. Okay, so now I have it running. So if this package, as I said, it only works if you have a real ROS, if you have a real robot of Spot. But that's the reason it is not a simulation based thing. It is just a visualization tool. So right now we cannot simulate this, but what we can do is we can visualize it. So for visualization, it uses this launch file, which is viewrobot.launch. Okay, so let's check it. Let's try running this launch file. So I will do ROS launch, the name of the package, which is Spot ROS or Spot Viz, sorry, Spot_Viz, and then view robot. So just let's check what is in this board. So it has joint state publisher and RViz, view model, and what is in view robot? It's just RViz. So we will launch this view model. Okay, so I will do view model dot launch. Now if I do this, it will launch, hopefully launch RViz along with the robot model. And now it's saying that there is no ROS master. Okay, I got the error. Just a minute. This is something which is because of the tortoise bot. Let me just fix it. Yeah, I have fixed this thing. Now if I close this terminal and open up a new one, and if I launch the same package, yeah, it should work now. So Catkin make is not usually needed. Catkin make is only needed if you are you have some C++ packages, like C++ scripts into your package. Other than that, Catkin make is not usually needed. It's good practice to do it, but I usually avoid when I know it's not needed. Okay. So you can see we have Spot robot over here. So they have provided a detailed model of Spot. See, this is the spot where this is the place where one real sense is placed. This is the back of the robot with another real sense. This is another side of the robot, so 3 real sense and 2 real sense in the front vertically, as I said. So this is how the robot is being placed, and we also have this joint state publisher. So using this, I can control each and every joint of the robot. So I know this is like the front right knee over here. I can move it like this. Okay. Similarly, I can left hip, right hip. Where is the right hip? Yeah. Front right hip. You can do something like this. So this was a visualization package. So what I thought was, if I have these models, so if you go into the package, I will show you the package and open the package and show it to you. So into SRC, Spot ROS. So here, if you go into description and meshes, so technically you have all the meshes of Spot as well as the material which is needed. Okay, they are all DAE files. So what I was thinking to do when I discovered this package was, I can just use these meshes. Okay, I can use the joint state publisher, I can use the coordinates of the joints and add physical elements. So whenever you want to simulate a robot, you need a physical elements, like you need inertia, you need weight of each part, and also you need friction parameters and a lot of stuff which are there in the Gazebo file. So what I thought was, we can add this manually. So I was just going to start doing that. I was going to build the whole package by myself. But before doing that, I thought, let's search the internet a little bit more, and let's find out if anything else is already there which is similar to this. Okay. So what I did was, I did a little bit of research, and I came across a very unique company which is very hard to find. Okay. I find Spot Mini ROS Package. Yeah, so everywhere you can see only the clear path robotics blog. I searched when I searched it for the first time, it was like on the 7th page. So I don't remember the name of the company, and I cannot open my search history right now over here, but still we'll try to find it again. So what I searched was Spot Mini ROS Simulation Package. Okay, so right now it's my first video. So let's find more. Yeah, system intelligence. Yes, this was the thing. So this was the company. This is the company who did exactly what I was going to do, which was like taking up the mesh parts and adding physical materials to it and all those things. So they had this Spot SDF, and they also had a gazebo interface, sorry, MATLAB thing, and they added everything which was needed in MATLAB. Okay. So they did this thing, so in which we can twist the robot and a lot of things. Okay. And from this, there is one more company, SoftServe. Yeah, this one. Yeah. So this was another company that helped me. Like they also did the same thing. So here, if you go for it, why do we need ROS drivers? So it says, if you go through this complete blog post, I will leave links to all these blogs down in the description after the stream is over. So they said the same thing, like we need to have physical parameters like the mass of the robot, the inertial parameters. They have explained the same thing. So this SoftServe Robotics, they made the complete package, and they made a gazebo simulation. After that, there is an open source package which is Champ. Okay, so I used to know about this package very previously, but I didn't ever tried it out. So this Champ package is made by an author who made Linobot. So Linobot is another robot which is like based on ROS, and it is an open source differential drive robot. So if anytime you want to make a differential drive robot, you can just come to this package. You can just put down the parameters of your robot, may it be physical parameters, the wheel diameters and all those stuff, and this package will take care of everything else, and you have a running complete, what we say, differential drive robot, or a Magnum wheel drive robot, or even a 4-wheel drive robot. You can use anything, or even an Ackerman steering. They recently added that Ackerman steering as well. So you can do anything with this robot. So the person who made this Linobot package, he himself developed another package which was Champ, and this Champ had similar ideology which was there for Linorobot, where you can come with your own robot design and you can have it running with autonomous mapping, navigation, and all the ROS related stuff. So he introduced Champ for quadrupedal robots or quadruped robots. Okay, so you can see there is another company like Boston Dynamics, which is Anybotics. So they made their own ANYmal robot, and you can get their controller as well on this package. There is MIT Cheetah. There is a Spot Micro project as well, which is an open source robot which looks like Spot, but it is a hobby grade robot. Okay, yeah. So the same person made all these packages, and when I searched out this package, I saw that there is Spot Micro and stuff, but I didn't read it properly. So if you go through this, they say that they have this Boston Dynamics Spot and Little Dog. They have pre-configured URDFs. So when I came across this blog post, at that time I understood, yeah, oh, these guys have it already. So instead of making, I just like imported this package and tried it out, and it worked flawlessly. So today I will be showing you how you can implement this package. But when I was implementing, I faced a lot of issues as well. So let's try out if we get those errors on this computer as well. If not, then that it's really great. If you guys face any issue, just let me know in the comment section. I will be there to help you out. And there was one error which I found in this package, which I have solved it, and I have put it on my GitHub. So if you go on to github.com/Pranshu/Tople/champ, I recently pushed an update which was 1 hour ago, and that was the reason why this stream got delayed, because I found this issue that these models, there are some models in the environment. If you go down, you can see there are plenty of models here, right? So all these models, author considers that these models are being downloaded on your PC, but not everyone has it downloaded, and Gazebo takes time to download all those models. So eventually everything fails and Gazebo never loads if you are connected to internet. If you are not connected to internet, then it loads without all the models. So that is what used to happen. So what I did was I added all those models manually right now. So if you just go fix Gazebo spawn error, which was 1 hour ago, so I've added all those models manually, so none of you can face this issue ever again. So, I will, if you are trying it right now, so I will prefer try my repository. So I will be leaving links to both the repositories down in the description after the stream is over. So it's just champ. So it's like you can go to github.com/Pranshu/champ. So now we will be downloading this repository, but even just like we downloaded it for Spot, the previous package, it has some prerequisites. So we need to install those. So first copy this command, open up a terminal. Okay, and I will close this existing thing. Yeah. I will paste it. So it will install the Python ROS dependencies, which I guess is already installed. I will just do it once again, but still. Oh yeah, it says it is already installed. No worries. Then we have to go into our workspace and to our src. So I will do cd catkin workspace/src. Okay, and then we have to git clone this thing, but you can see it is giving the path of the champ. Here we will be downloading my project, so I will do git clone -recursive, and then I will give link to my project. So https://github.com, sorry, so github.com and /Pranshu Tople/champ. So it will download this repository from my forked repository. Okay. The next thing you need to do is you need to install the teleoperation package as well. So just like differential drive robot, you can just control the robot. It will go forward, backwards, left, right. It will rotate actually, yeah. But here in quadruped robot, it can go sideways as well as there is possibility like the quadruped robot can tilt like this. It can rotate like this. It can do a lot of stuff, right? So for that thing, they have made their own teleoperation package. So we need to clone that as well. So you can directly clone this from their repository. There is no issue in that. So I will clone that as well. Yes. Okay. And then one more thing we need to do. This, as I told, champ package, it has the package for the champ. So it has the configuration files for champ, which is a robot. But we want to try out Spot Mini, right? So for that, if you go onto their repository, yes. So here, if you scroll down, there are some robots. There is this repository robot. Don't worry, I will leave links to these as well in the description. So they have named this Zoo because this package has all the different kinds of robots, like quadruped robots, which are open source, and they are available over here. Okay, so if you go down, so the company ANYmal, they have two robots, which is ANYmal B and ANYmal C. They have both of them. Boston Dynamics Spot, they have it. Boston Dynamics Little Dog, also they have it. Unitary Robotics Aliengo. Unitary Robotics is another company from China who is the competition to buy Boston Dynamics right now. They are making cheap commercial quadruped robots. Then we have MIT Mini Cheetah. This is by the MIT Massachusetts Institute of Technology. And then we have Open Dog by James Bruton himself. And then we have Open Quadruped, which is another project by a person who is working in Boston Dynamics. Okay, so if you go onto this link, yeah, this is made by Moribots. So this person, Moribots, is working in Boston Dynamics. Okay, I think we can open it from here, or we can. Yes, we can open. So he has made this robot which looks like Spot, but it is a smaller version. And finally we also have some other robots as well. This Scotch Light, which is another robot. This is by an Indian student. I don't know from where exactly he is. I guess he is from IISc. But yeah, so this is another project which is available over here. This is their robot. So you can try out all these robots. I guess I closed it. Okay, so these are all the robots which are available in this zoo. So we need to install this zoo as well. Okay, so I will just copy this link. Okay, and I will paste it. I will do git clone paste. Okay, but now this zoo already has this Spot package which we just downloaded. So if you go into here, Spot config, not here exactly, it will be here somewhere. Yeah, so the configuration files which are needed is already there. So the recently downloaded package which we did was it. Yeah. So if you go on to this robots configurations, you can find Spot configuration. And if you just go into here as well, Spot config. So for each robot you need to install their description files as well. If you go over here, install descriptions, so here you can see each one of them you can install it personally. Okay, so we have all we wanted this Spot thing. So what we can do is we can copy this, just this thing. Okay, if you want to install all of them, simply what you can do is you can open up a terminal, you can navigate into this path which is cd robots, and then type in install descriptions. If I press enter right now, it will download all these things, but I don't want all, I just want the Spot Mini. So I will just download this, I will copy it, and I will go back to src. Okay, make sure you are downloading everything in src, and I will clone this package. So it says Spot ROS is already there because we recently downloaded that package, but the package we are going to download right now is a little bit different. So I will delete the existing package, this Spot ROS. I will delete this existing one. Now I will clone this new one. This has parameters specifically for the champ. Okay, so that's the reason we are downloading the new one. Okay, so if you go into this, see it already has this description thing. It has messages and everything which is already needed. Okay, now if everything once downloaded, then if you just check onto here where it went, so once everything is done, then we have to go into the catkin workspace directory. So I will do cd ... and then you have to run this command. What this will do is it will install all the dependencies which are needed by each package. If anything is not installed previously on your machine, it will do it automatically. It will try to do all the packages by itself. If anything fails, then we can do it manually later on. I'll also tell you how you can do it manually. By the time it downloads, let's check on the chat. So Sahal says that Catkin build is much greater than Catkin make. Yeah, it takes a lot of time, so that's the reason I don't do usually Catkin build. But yeah, right now I am doing it. Right now I am just like downloading all the packages, and after this I will do Catkin make. It is necessary for this Spot package because there are a lot of scripts which are dependent on that. Okay, so make sure you do that. Okay, after that, let's is there anything else? Do you think Windows is doing great job with WSL 22H2 update? There is no more need of fuel. So Shivam, I still don't recommend WSLG. Okay, I have instead of that thing, you can watch my recent video on how I have done like installed ROS on Windows without using WSL or dual booting. So that thing is definitely better. I don't recommend WSL because still it's a virtual environment, so there is some file storage and file configuration problem, so that's the reason I don't recommend WSL. But you can natively install ROS on Windows. Yeah, but definitely WSL which has GPU support, it is really great. It is really great. I've tried it out. It's really nice. But still, you can install natively right now, and I have already made a video on it. So if you haven't watched that video yet, go and check it out. I said that once we reach 250 likes on that video, I will be releasing a second part on that, like how you can make Catkin workspace in Windows and how you can use simulate robots in Windows. So, but we have reached only till 150 likes, I guess. So go guys, go and like that video, share it with your friends, tell them to like, or else you won't get that Windows ROS on Windows video. So please go and like that video. Okay, and add links to the website. Yes, Sahas, I will be adding them once the stream is over. I will be updating the complete description of this video, so I will be having all the links. Right now, if you want to check it out, you can just check it like on the top of the video, like here. Okay. It's great, Rajmit, that you are working on ROS package. Second, can you just share the screenshot with me on Instagram so that I can tell you how you can solve this error of Catkin make? I will tell it to you, okay? What is haptics in robotics? I don't know what is haptics. I'm not sure from where did you got that word. Oh, so it is a glove which gives you haptic feedback. So it's in virtual reality. So I have a virtual reality headset with me. So in that I can do hand tracking. But in that, if I pick up some object, let's consider if I am picking up this in virtual reality, I don't feel anything. I can just push my fingers to the complete extent. While in reality, it should be something like this. So haptics is what I think, which I can see is a mixed reality glove which restricts your motion of the fingers as well as it gives you haptic feedback, so you feel like you are holding something virtually. That is what haptics is. Okay, and it is used in as you can see, it is used in robotics. So right now a UR5 robot is connected with the cup, so the person don't have to completely squeeze his hands. He can just hold it like this and the cup will be picked up. So that is why that haptic gloves are being used in this. Okay, and yeah, Turtlebot tree is not launch file traceback. What is the error and how to handle this? Please make sure that you have Turtlebot 3 named package. I don't think Turtlebot 3 underscore is some package. Okay, you need to give proper package name. So you have to give Turtlebot 3 underscore Gazebo or Turtlebot 3 underscore simulation. It can be any package or underscore navigation. So please give the complete part to the package. Okay. And second 4294, if you want to learn more about it, go and check out my previous videos. I have made a lot on how Catkin workspace works, how to do Catkin make. So go and check out those videos. Okay, that will help you a lot. Oh, that's really great. It's used in train to doctor's surgery. Yeah, that's really great. Oh, this is the one that Jeff Bezos used. Oh, that's cool. Okay, so let's get back to the installation procedure. Is it done? It says it failed. Hector sensors. Okay, it's okay. Hector sensors are not needed right now, so it's okay. So now, as I said, once that is done, once all the dependencies are being installed, do catkin underscore make. Let's wait for it to do. Let's wait for it to complete. How many of you guys are watching right now? It's 20 viewers right now. That's great. And just 25 likes. Sorry guys, come on. We are revealing the secrets of the big Boston Dynamics. So come on. like this video. And yeah, one more thing, this package is not officially provided by Boston Dynamics. Boston Dynamics has not revealed any of their secrets right now, so they have kept Spot simulation with themselves. I don't think even they have used any simulation, but they have all the controllers packaged by themselves. These packages are been made by individual creators. Like as I said, the person who made Linobot, he has made this champ package, and as I told, the other company, which was this thing, what was the name? Soft Serve. Yeah, this company, few people have this Soft Serve company made this package by themselves. Like they used the meshes that were available, and they may add the controllers, they added physics by themselves. Okay, so this robot simulation model cannot do all those cool things like bouncing on one leg, bouncing on two legs, that it cannot do. But definitely if you work on it, you can make your own similar package. But there are a lot of things that it can do, which I will be showing you right away. In fact, this thing can be controlled using a joystick as well. So I will be showing you that as well, like how you can control a robot in simulation using a real joystick. So stay tuned for that. This will be happening today itself. We will be completing this thing and then we'll be moving forward. Okay, so 81% done. Thanks, Chaitanya. I'm glad to hear that. Can you make any tutorial video for the F1 10th simulator? I haven't heard of that, Harsh Agrawal. F1 10th simulator. Let me check. Oh, F1 10th. Okay, I got it. This is the F1 car. Okay. Yeah. Definitely I will try. I haven't tried it out. I have seen its post on Twitter. I've been seeing that it is like in the limelight right now. So I will go through it. I will try it out, and yeah, definitely I will make a tutorial on it. Okay. Thanks for telling that. Please make a Move It plus Robotics Manipulator tutorial. Yes, the Move It and Robotics Manipulator tutorial is coming soon, and it will be specifically for James Proton Robot. So if you go over to his YouTube channel, if you remember his robot of really useful robot, it has a robotic arm on itself, like this one. It can hold let me mute it. So we will be using this manipulator, but in his video he programmed it using Arduino, but in our case we will be using Move It for it. Okay, so that video will be coming as soon as well. Okay, along with that I will be also adding a RealSense video. So in that RealSense we will be using the RealSense to detect objects, and then we will be using the hand to go at a specific object and pick it up. So yeah, that is coming really soon. Have you encountered an issue in Gazebo that models start dancing and flying and all the links fall down? How to fix that issue? Yes, Shivam, that is a very common issue. So a video is coming pretty soon for that as well. But if you want to solve that problem, go on to my previous videos, and I have some comments which will help you solve those things. Okay, so I was recently helping out a person for that. So here it tells that there are some issues. So if you go on to this mapping the virtual world, so for that specific problem, there are two things. There is one, this mapping virtual world in Gazebo, moving robot in Gazebo simulation, and converting robot to URD. Go through these 3 live streams as well as go through the comments. So there are a lot of people who have faced similar issues, and I have tried to solve them, solve those issues in the comment section. So you can go through the comment sections. And if you are lazy to do that, then don't worry, I will be uploading a video pretty soon for that. So maybe within this week the video will be coming, so just stay tuned for that. Okay. Yeah, Aman Singh is one who was facing that issue, and I shared, I guess, with him as well. Yes, Serhat, I will be doing the movie integration and inverse kinematics on the this really useful robot by James Bruton. So I will be most probably doing it the coming Sunday, I guess. The coming Sunday. Today is Sunday. Today is Saturday. So the next Sunday I will be doing a live stream for that. So yeah, make sure you attend that live stream. Okay. Let's see if it downloaded, if it is done. Yeah, 100% build target done. So there is no issue right now. So to start this spot, okay. So if you go over to here, as I said, there is not this one, Spot ROS, sorry. Where is that zoom? Yes, robots, configurations, spot config. Yeah. So here you can see all the commands to run the spot. Okay. So let's say ROS launch spot configuration bring up dot launch. So let's test by this. I will copy this. Paste it. So this will open up RViz along with the robot. Okay. So what error is it? Let's check it later. Let's see if the robot is spawned. Yeah, you can see the robot is being spawned. Okay, so the problem here, which you can see in the terminal, was the model hector sensor. So this is because if you remember previously we saw a problem that hector sensor was not downloaded. So in this case there is a hector sensor lidar on top of every robot. So that is being not loaded. So let's download that. Okay. So to download this package, all these errors are about the same thing. So I will do again this ROS dep install. It says installation of ROS melodic hector sensor description failed. So let's try to do it manually. So I will type in sudo apt-get install ROS-melodic / sensor description. Okay. Okay, just wait a minute, I was in the wrong directory. So I will go first into SRC. What does it say? IP not found, unable to fetch some archives. Please run apt-get update and try to fix missing. Okay, so I will do sudo apt-get update. So this is the cleanest thing about Ubuntu. It usually gives error, but it tells the solution by itself. Okay, so you put a habit of reading those things. Okay, I will also do upgrade for once. Upgrade. I will upgrade all these packages. Yeah. So usually it gives all these solutions. The solution is right in front of you. The only thing you need to do is to read it properly. Okay. First time watching any ROS robotics content, just here for you, Pranshu. Thank you, Techie SMS. I am very glad that you came over here. So guys, Techie SMS is a really great YouTube channel about Arduino and IoT related stuff. He's the one who inspired me. He's he crossed his 60k mark, I guess he's close to his 70k as well. So go and subscribe to him. It's a really great channel if you want to learn about IoT related stuff. It's the best channel I can say. Thank you. Yeah, I can understand these codes and everyone terminal running, so it can be new for you. So yeah, so right now we are just trying to solve some errors that we are facing, and hopefully we will be able to run it. Let's wait for it. Until then, let's check out some more chat. Can we perform inverse kinematics? Yeah, I already answered that. Yes, we can. Please add auto RRT path exploration in James Proton robot. Yeah, sure, Deep Roy, I will add it into his package as well. So if you go and see his package, he has already accepted my git commit. Okay, so if I go into github.com, I guess it's X robots. Yeah. If you go on to really useful robot, yeah, so here you can see he merged the pull request from me. So all the simulation thing related things. So as you can see, this was my tutorial series which is already published over here. You can just click on it and you can land onto that specific video. So it's completely there. I have also added some GIF, so you can go on and check it, like how you can move the robot and like how all the links of the robots are there. Also how you can generate map of the surroundings. So everything is given over here, and I have added GIFs. So as you can see, this map is being generated as it is going, and after map is being generated, we can do autonomous navigation. I have also added some GIF for the same. So here you can see this robot is going from here to here. So it is like moving around this path. It is completely automatic. Yeah, Tech SMS is around 66k. So guys, go like I have around 3000 subscribers, so we can just make it 69k. So go and subscribe to Techie SMS. What can I expect in the end? So Techie SMS. So this in this at the end of the video, we will be simulating a robot which is a quadruped robot by Spot. So I have already added it into my community post. So a couple of days earlier. So you can see this robot. So there will be a 4-legged robot, and I can control it manually using this gamepad, or else I can just give it a goal anywhere and it will go there autonomously. It will avoid all its obstacles and it will do completely autonomous navigation. I won't be doing anything. So that is what it will be doing by the end of this stream. Yes, I am making a project on this live stream. So I'm technically I'm not making. I have solved some issues in this package, and I am making a tutorial on how to use this package. So that's what I'm doing. So yeah, I guess this is done. Yeah. So what was the error? Let's run it once again. It says apt-get update and try fix missing. We'll do that. I guess there is some problem in fix missing. This is not the exact way to run it. Get install fix missing. Okay. So go at get install fix missing. Yeah, this should be done by now. And if we do this again, let's go and check out what is there on the list. I can open this link from here. Okay, so the link is not available. So let's try downloading this package manually. So we are trying to download ROS melodic fiction. I will just copy this, paste it, and we will try to find out if we can find it. Hector sensor description. There we have it, melodic. I can go on to this GitHub branch. Hector models. We have hector sensor description. Yeah, we have it. I can simply copy this thing. I can go into SRC. Yeah, we'll do git clone this package. It will download all the hector models. Once that is done, I will go into Catkin workspace and do Catkin make, which is the usual thing that we always do. Techie SMS, don't get worried. This is the common thing that we do over here. So well, this is exciting. Will you post the project for us to try? Yeah. This is completely posted on GitHub right now. I will be adding all the links down in the description. So once the stream is over, all the links will be available. Don't worry about that, you can try it out. Joseph L, is it Lentin Joseph? If it is Lentin Joseph, please let me know in the comment section. Yeah, sure, take SMS, grab a popcorn and sit. Yeah, done. So this was what we were waiting for, 100% done, Kathleen make. So now hopefully we will be able to follow these instructions over here. Where is it? Yeah. So we'll start the RViz again. So I will just paste this command. And remember, previously there was just a robot, there was nothing else. So hopefully if everything we have done is correct right now, then we should have a laser sensor, like a LiDAR on the top of the robot, and here we have it. So just like I have this LiDAR on the top of this robot, so similarly we have this LiDAR on the top of this robot. So this will help it make a 2D map of the surrounding. Okay, and there is a depth camera as well in front of the robot. So everything is proper in this. So what we can do is we can control this robot as well. So to control this robot, I will show you. There is this champ teleop. Okay, so I can open it on a new terminal. I will open a tab in new terminal and I will paste it, hit enter. So now using my keyboard I can control this robot. So if I press I, it will start moving forward. Okay, so right now I'm pressing I, it is moving forward. If I press comma button, which is just below K, it will move backward. Okay, now if I want to rotate it on spot, I can press J and L to rotate it right and left. So it's now moving right, it's right now moving left. And what if I have to move it sideways? So I will press Shift and J, so it will go sideways. So either you can rotate it like this or you can move it sideways. Same goes with the other side as well. So I can rotate it or I can move it sideways. Similarly, if I want to go it forward left, let's say, so I can go move it, make it move like this, like it's turning towards left and it is also going forward at the same time. And if I press Shift and U for forward left, I can, like it is going diagonally, but the face is staying right in front of it. Got it? Now I will show you one interesting thing. I will close this thing and we can add a parameter in front of it. So right now I have this controller, joystick controller. I will connect it to my PC right now. Just a minute. We will control this robot using our joystick. Yeah. If I turn it on, yeah, it is connected. And if we go over to here, again on the same GitHub page, there is the teleop package. Yeah, teleop, yes. So here we can see joy true. So this, we have to run this command. Okay, so I will open up the everything which was there, and here I will type joy. Okay, now if everything goes well, yeah, so now I should be able to control the robot using this. So if I move the stick forward, the robot should start moving forward. If I move it backward, I can rotate it like this as well. So this is like a complete 360-degree thing. And there is one more interesting thing. This right joystick can make it move, do stuff like this. So I can rotate it. So I will just face it towards the camera. Okay, so yeah, I will make the camera go a little bit closer. Yeah. So now I can make it go like this, like down, up, and also sideways. It can look sideways. Okay, along with that, if I press this R1 button, so now I can make it go sideways like this. So this will be, we will be seeing in simulation. So in that it can rotate itself, and along with that it can also like sit. So if I this button, this is the analog button. So if I press it a little bit, so yeah, it should go a little bit down, and if I press it fully, it will go completely down. And yes, you can jump like this. So right now this is visualization, so it is just telling the joint position. So now if you want to jump, you need a simulation for that. So let's check out the simulation. Okay, I will close this visualization of the robot. Let's jump to the simulation. Okay, so there we go. So for simulation, where did it go? Robots, yeah, configurations, Spot config. Okay, here if you go into this, you can run a Gazebo environment. Okay, I will copy this command, I will paste it in the terminal. Okay, so now we are loading a complete simulation with the robot. Let's hope it works. So we will add some lighting, the point light. I will change the I guess the lights are not getting rendered, but we can increase the brightness over here. Yeah, I guess this is better. Yeah. So now you can see we have this robot and it is in a place where all the, what we can say, a kind of disaster management kind of an environment where you can see there is a building which is being broken down. So these kinds of robots are used in similar kind of environment. So you can see there are some SUVs and there is some barrels for construction site kind of thing. There is also a crane, tower crane, which you can see like it's pretty huge. Okay, yeah, there is a tower crane. So we have this complete simulation environment, and in this simulation environment we can make this robot move. Okay, so let's start it. So as I said, we can start the same node which we used for controlling the robot. Okay, and using this I can move the robot again. We'll just tell it to go forward. Wait a minute, reload properly. I will just have it over here. Yeah. Okay, so the simulation is running at a very low speed at my side. Okay, so it's like 0.1. That's the reason you can see the robot is moving really slow, and maybe you can find some like problem in my stream as well. But yeah, this is how it's working. And to make the robot jump, I said this is the button, so I can put it like this. So now it's completely compressed. Now I can leave this button and it will jump. Okay, I will just adjust it a little bit. Yeah, so now you can make the robot move however you want. So I will just make it rotate. Right now I'm streaming and that's the reason it is being very slow. You can see it's slow. So the real time factor should be close to 1, but it is like 0.1. So it means that it is 10 times slower. Okay, but you can see it can do all the stuff. As I said, it can do up and down, it can go sideways. As I said, this is the thing, it can do sideways. Okay, and then what else it can do? Can just bend it like this and can move forward. So all these things we are doing it right now manually. So this is one thing which we can do. Not only manually, what if you want to make the robot navigate autonomously? How will you do it in that case? Okay, so I will close this existing thing that I am running and I will show you how you can do it autonomously, so without any controller. Okay, Answer. Okay. What software is this? I am just starting with robotics and never even thought about simulations. Okay. So it's not Lentin Joseph for sure. Okay, so this software is Gazebo. If you want to learn more about this, I have made plenty of videos on my channel. You can just go and check it out. So you will be able to see what all packages did I make and what all things you can do in simulations. Okay. Also changing the view in orthographic for some reason. Okay, fine. Thanks, Vaibhav, for the cool controller tag. So, yeah. So now, as we said, we can tell you a bit. But what if you want to map the surrounding? Okay. So here you can make the map of the surrounding. You can run this lamp node, and as you can see, the robot is moving and it is making the map. So you already have that over here. Apart from that, if you want to do navigation, in that case we will run the same launch file and there is a navigation.launch. So I will copy those things. Okay, I will first launch the simulation. Everything is given onto this GitHub repo. So you can go and check it out later on whenever you wish. Okay, whenever you have time. Or once the stream is over, I will also upload it in the in the descriptions. So do check it out. Okay. Yeah, we have the robot over here, and on the other part, we'll launch the navigate.launch. Okay. So now in this case, as I told, we have a LiDAR on the top of the robot. Okay. So using that, it is making a 2D map of the surrounding. Let the RViz load properly, and yes, and we can see that RViz is loaded. Let the robot model load as well. Yes, now you can see robot model is also loaded in the RViz, as well as you can see these colorful dots. So these are the readings from the LiDAR. If we zoom out a little bit and if we rotate it somewhere like this, we are getting this view in our RViz. So here RViz is the visualizer and Gazebo is simulator. Okay, so simulation is like if we don't have a real robot, then we are simulating it. We are making a robot which is virtual robot, you can consider. And this visualization is for understanding how our robot is behaving in simulation. So for that case, we are using visualizer, which is RViz. Okay, so now what I will do is I will give it a 2D navigation goal. So I will select this 2D nav goal and I will just tell it to go somewhere over here. So now the robot will make the path automatically and it will go over there. Okay, it will go there autonomously. We don't have to do anything. So right now you can see the robot started moving. So we can give it path anywhere into this arena and it will go there autonomously. Thanks Dinesh for the super chat. This is my second super chat for today. Like for not today, for forever. Like this is my second live stream. In my first live stream also I got a super chat, and this is my second live stream in which I got super chat. So thank you very much Dinesh for supporting me. Can this robot be controlled using ROS publisher and subscribers? Yes, Aman, this can be controlled using ROS publisher and subscriber. This is completely based on ROS. So if you just go and search ROS topic list or ROS node list, you will get all the nodes and you can check it out on that. Okay. Can you please show the topic that are being published in the simulation and running? Yeah, sure, I can show it to you. That's a really good question, by the way. So I will just show it to you what all topics are running. So I will open up a tab. I will type ROS topic list. So there are plenty of topics that are running in that I know. Yeah. So this scan topic is the scan which you are getting from the LiDAR. Okay, these are some velocity smootheners because we don't want the robot to go at full velocity and stop automatically, right? And again then full velocity and stop. We don't want that. So for that we are using velocity smootheners. After that we are publishing odometry values from the robot, so it tells where exactly the robot is. After that there are a lot of movies related things, maps, joint state publisher for each and every joint of the robot. So these are all the joints. we have the IMU data as well, so we know what is the orientation of the robot. And is there anything else? Command velocity, as I said, we are using command velocity to send command to the robot. And we also have camera. Yeah, I forgot about the camera. So if you want to see the camera view, let's check it out. Okay, so run RTT image view. RTT image view. We'll be seeing what exactly the robot is saying. Okay. Is my stream lagging or something? Okay, I guess there are a lot of things running, that's the reason. Okay, so let's check out what was the camera RGB image. Yeah. So this is what the robot is seeing right now. Okay, so if I give it another navigation goal somewhere over here, so it will try to rotate. Okay, so let's give it a goal. Now you can see the live feed over here onto this. So when it is going, it will also try to avoid all these obstacles which are there. So these barrels and everything, it will try to avoid. Right now it is detecting it is pretty close to obstacles, but it will still avoid it. Don't worry about that. They have tuned the parameters really well. I'm not sure about this small obstacle which is right in front of it, but apart from that, it will try to avoid. Let's see what happens about this. Okay, by then let's check out some chat. So, did you learn this in college and university? No, Shakti, I didn't learn it in any college or university. This is all self-learned, this is all self-taught. So, but yeah, definitely, if you want to learn it, I have started my own course like ROS mentorship program. So you can apply for that ROS mentorship program and you can learn all these things. Okay, so if you want to check out ROS mentorship program, you can go on to rigbitalabs.com/ROS mentorship program. I will putting those links down in the description. I guess the stream is lagging because of this simulation. So I guess you guys have got this understood how everything is working right now. Stop this simulation. Is it better? Yeah, I guess it is better right now. So I'm really sorry for the lag, guys. We were running a really heavy simulation right now, so that's the reason it was lagging. But I hope you understood how everything is working over here. Don't worry about it. I will be leaving all these links down in the description. So the next plan is like right now I told you how you can control it using a controller. I showed you how you can make a map of the surrounding using this launch file which is right over here. And finally we saw how we can navigate it autonomously. So all this is provided in this package. You can have your own robot made and you can configure it and you can use it using this package. So for that, for making the configuration, if you go on to the original package, which is champ, there they have explained that there is a setup assistant. This setup assistant, so in this you have to load the URDF of your robot, and they have given all the process in detail over here. You have to define all the links of your robot and everything. So once you do that, you have your complete robot ready in champ package, and using this champ package you can make it make all the calculation completely autonomous. You don't have to do it yourself manually. So I will be taking advantage of this and I will be making a really cost efficient quadrupedal robot really soon. So stay tuned for that, and that's the reason I started this stream today, because I wanted to show you what all things you can do with this package today. Okay, so stay tuned for the next video when we will be making a real robot, which will be a real quadruped robot, and we will be trying out this package on it. Okay, thanks Chaitanya, thank you very much. How can we add sequence path for autonomous navigation in this robot? So yeah, so you can implement waypoint navigation in the same way you do it with any other robot. So if you just search waypoint navigation on internet, you will get a ton of tutorials on it. In that case, what happens is you tell multiple points to the robot and the robot goes over there one by one. It all happens autonomously. So in the same way you give it to any differential drive robot or any other robot, you can give it to this robot. This exactly works like a normal robot, just the difference is that instead of wheels it has 4 legs. That's the only difference. And that was it for this video, guys. If you have any doubts, please let me know in the comment section, and if you have any questions, you can ask right now, or we will be ending the stream soon. I guess there is no more questions, so thank you very much for attending today's session. It was really great. We faced a lot of issues in starting, and I know it was very thank you guys for keep like waiting and not abandoning me, and I will be uploading more videos about this, so stay tuned for that. Next time GPS navigation with ROS, please. Yeah, sure Pratik, I will definitely look into it, and I will be making a GPS navigation robot soon. For the suggestions, and